Operating with surds. Now this is all about using surds as algebraic quantities. So what do I mean by that? The rules for adding, subtracting and multiplying with surds are analogous to those for ordinary algebra. The following examples will illustrate this. So we're going to start with 5x plus 7x. Now this is something you should know how to do. If you have 5 x's and then 7 more x's, altogether you have 12 x's. So if I have 5 lots of root 2 and then 7 lots of root 2, altogether I have 12 lots of root 2. Now here we have 4a plus 5b plus a take away 7b. So what we do first is look at the a's. I've got 4 a's and I add a single a, so that would give me 5 a's. And then I look at the b's and I've got 5 of those, but then I take away 7, so that's minus 2b. Now, let's look at the same thing, but this time we have root 2 instead of a and root 5 instead of b. So 4 root 2's add a single root 2 is going to give me 5 root 2's. 5 root 5's take away 7 root 5's would give me minus 2 root 5's. Just look at how it is analogous. So now let's expand this bracket. Well, you know that you do this multiplied by this. So that's 5 multiplied by 3 is 15. And then we do this multiplied by this, and in that case that's going to give me 10 x's. So here I'm going to do this multiplied by this. Root 2 multiplied by 3 gives me 3 root 2. And then this multiplied by this would give me root 2 multiplied by 2 root 2. So that's 3 root 2, but this can be simplified here. 2 root 2, remember, means 2 multiplied by root 2, and then we're multiplying that by root 2. So that's 3 root 2, add 2 multiplied by root 2 multiplied by root 2 is 2. That's the very definition of a square root. So we get 3 root 2, add 4. Now let's look at this pair of brackets here. So we know that we get 2a squared. And then here, that's going to give us 5ab. This will give us 6ab. And then finally this would give us 15b squared. And then we can tidy up 2a squared plus 11ab plus 15b squared. So, same sort of thing. So we're going to expand here. So that would give me 12. This will then give me 3 lots of 3 root 3. So that's 9 root 3's. This then gives me 4 times 2, so 8 root 3's. And finally, 2 times 3 is 6. So that's going to give me 6 multiplied by root 3 multiplied by root 3. So the 2 times 3 gives me 6, and then root 3 times root 3. So that's 12. And then these two together give me 17 root 3. And then root 3 times root 3 is 3, multiplied by 6 gives me 18. And then 12 and 18 gives me 30, so I get 30 plus 17 root 3. Okay, so we have 3 minus root 2 equals squared. Now we know that when we square something, it means that we multiply it by itself. So that's going to give me 9 minus 3 root 2 minus 3 root 2, and then finally minus times a minus gives me a plus. Root 2 multiplied by root 2 is 2. So 9 and 2 is 11, and then we have minus 6 lots of root 2. Now this one, I'm just going to highlight this, is really important. Note that both brackets contain 3 and 2 root 5, but there's a difference. One of them's a negative and one of them's a positive. And what's going to happen in this case is that we won't get a cross term. Basically, the terms that involve root 5 are going to cancel out, and we won't have any root 5s in the answer. This is really important. It's called a difference of perfect squares, and you're going to come across this quite often. So 9 plus 3 times 2 is 6, so we have 6 root 5s. Then we have minus 2 times 3, so that's minus 6 root 5. And then negative times a positive gives us a negative. 2 times 2 is 4. And root 5 times root 5 is 5. Note how these terms cancel out. So we get 9, take away 20, which is negative 11. I said it was a difference of perfect squares. A squared minus b squared always factorizes as a minus b, a plus b. And this is really important, and we're going to use this one in the next section. Note what we could have done here had we spotted this pattern. We had an a minus b, a plus b, and in our case the a was 3 and the b was 2 root 5. So we could have straight away said that this was 3 squared, take away 2 root 5 squared, which is 9. And then think about 2 root 5 squared, that's 2 root 5 multiplied by 2 root 5, which is 2 multiplied by 2 multiplied by root 5 multiplied by root 5. So it's 4 times 5, which is 20, as we saw just here. So difference of perfect squares, really important, can save you time, and is very useful in lots of situations.